Alright, this is my last update for the panel controls using the microcontroller and the stepper motors. Right now I have it so that we have the MSP430 here, and it is sensing from, I guess, these sensors here. They come down here up onto the motors here. So as you can see, I made a circuit board and it's in here, and it's got one sensor right there. The other sensor, come on, focus, right there. And we have another one right there. Okay, and so right now it's the program is actually running, and it's pointed at the sun, which is my light. You can see that it's pretty much head on with the light up here. Here's the light. So yeah, it's looking right at it. And so what's happening is it's sampling from these sensors, and it's being brought back into the microcontroller. Microcontroller is processing these signals, converting them from analog to digital, and then based on the digital, it either rotates one of these stepper motors here, and it controls this output signal for the motors, goes into this this board here, which controls the stepper motors. I guess there's some other functionalities that I kind of want to talk about as far as controlling this remotely. So I wrote some script to send the data from these sensors to the computer serially, and I just recently figured out how to control this whole system serially, and so I'm going to run some of that on my computer and then and watch the system react to my inputs on the computer. So let's see, it's a pretty good view. Alright, so using the terminal here, you should be able to see it. I'm recording on my computer as well. So the input from, or the output from the MSP430 is unsigned integers, and so it only sends one byte at a time. That's all I can read here because it's using unsynchronous serial communication. So it can only send one byte at a time because it has no way of knowing when the next byte is coming because they don't share a clock signal. So that being said, we're hooked up on port 4 here, and baud rate's 9600, and I'm able to transmit signals to the controller. So first of all, let's start off with 5. When I push the 5 on my keyboard, it sends a signal to the microcontroller, and it says it sends the 5 as in I think it's 53 would be the actual number code for it. So it sends 53 in binary to the microcontroller. Microcontroller reads that, and based on the input of 5, it starts to send me back these values, and these values are the digital conversion of the analog signal of the 3 sensors. So you have sensor 1, sensor 2, and sensor 3. Now these are pretty much real time. We're getting 220 refreshes a minute, so each refresh would be one signal. So each one of these is its own transmit function, and then so these signals here can be seen real time or sent elsewhere, and I also made 4 other functions that I can send with the keyboard. So if I push, well, let's stop the transmit here. Oops, let me change that back. Okay, so we stopped the transmit function here, and now we just have, let's run it again here. Okay, we stopped it. Now if I press 1, it tries to rotate the motor, and 1 will rotate, 1 and 2 rotate motor 1 clockwise and counterclockwise, 3 and 4 rotate motor 2 counterclockwise and clockwise, and so so you can see that when I interrupted this whole system and I told it to rotate, it came back to its position where it's looking at the sun. Right now I'm not using the stepper motors, I'm not freezing them or blocking them, I guess, with current. Instead, once they've achieved their position, they just kind of turn off to save power. This will be the setup we use for controlling the actual panel, because we don't want to burn energy just sitting there and not changing position. But for this application where I'm actually physically holding the thing in place, I need to lock the motor. So I have a macro setup for when I push the button 6 on my keyboard, it's going to start locking the motor. Now, if I try and push 1, 2, 3, and 4 again, it's going to move it, but it's going to have a lot better response back to the original position. You can see it right now. It's more responsive. Now, if I try and move the motor, this bottom one, it automatically points back at the sun. So, and it's doing this all on its own. I'm not doing anything. But this does burn a little more power because I'm locking the motor. So I'm going to push 6 again over here, and I ran my macro to turn it off. So now they're free to move, and they can move to a position, but because of these heavy cables that are coming off of the sensor, it kind of moves back to its own position. And now that I have this, I figured out my next step is to figure out how to control this, or send like the 1, 3, 4, 5, or 6 to the microcontroller through a web page, and I think I'm going to try using PHP for that, and hopefully it works out. That's it for this